In lesson 89, we look at conjunctions, disjunctions, and the product of chords and secants. For conjunctions, those are and statements of inequalities. Now, the first thing that you do when it gives you these two different inequalities that are connected with and is just solve for your variable, in this case x, separately. So I would add the 3 here, so I'd have negative x is less than or equal to 1. And then I need to get rid of the negative 1 in front of the x, so I would multiply or divide by a negative 1, so that'd make that a positive x. Then it switches the sign, so it's greater than or equal to a negative 1. Okay, now we have the and in the middle. And then we'll solve the other inequality. We just need to add 2 to both sides, so x is less than 3. So we will graph where they intersect, and keep in mind that our domain is integers. So when it's an and statement, the numbers that satisfy one has to satisfy the other on our graph. So that's why we look for the intersection. So let me first kind of graph these separately. So x is greater than or equal to negative 1. Then we would have our 0. Because since it's just integers, it does not include any fractions or decimals. Okay, and this one would continue doing that to the right since it's greater than. And the other one starts at 3, but it's only less than. So it doesn't have a solid circle at 3, and it's closed at 2. 1, 0, negative 1, negative 2, and then this one would continue on to the left. Now, if you look here, I know that I don't have that exact, but they line up at the negative 1s and at the 3. So it's that intersection that we would only include on our final graph. Now you notice that on this one it didn't say equal to, so here we will not include that. We'll leave it that open circle instead of a closed circle. So our final graph, we have that negative 1, 0, 1, 2, and then it would end at the 3. But we wouldn't have it a closed circle, we'd leave it open. Okay, so we just include the intersection when it's an and statement. Alright, let's look at the next one. This is also considered an and statement, it's just now they've linked them together for this compound inequality. But you still follow the same idea of getting your x by itself. So you'll need to just add the 2 to all 3 parts. So I have plus 2 here, plus 2 here, plus 2 here. Alright, so this is going to be 0, less than x, and x is less than or equal to 6. So on this one we won't have to do separate graphs, we can go ahead and put this all on the same one. So it starts at 0, we'd have an open circle there, it ends at the 6, and we'd have a closed circle at 6, and then x is greater than 0 but less than or equal to 6, so that's just going to be shading this middle portion. So and statements, you're usually shading the middle. I call them innies. Then the or statements end up as outies, where you end up shading the outside. And those are disjunctions. They're or statement inequalities. So So again, we start the same way, where we graph these separately and actually solve for x separately, and then we see where they would intersect, and then our final graph only has their intersection. So on our first inequality, we would need to get rid of the -1, so that would be x is less than or equal to a -3. Or, now again, we're just getting rid of that -1, so it's going to be a positive x is greater than a positive 1. And these are, our domain is just the real, so we'll be able to shade and we won't have to just include the numbers. So we'll graph x is less than or equal to -3. And we're just going to go ahead and put these on the same graph. So -3 less than or equal to is a solid circle, shading to the left. Oh my gracious. Alright, and then at 1, x is greater than 1, so it's an open circle, shading to the right. And then you would be done. You don't have to do the two separate graphs. Alright, now we have another OR inequality, and this time our domain is integers, so remember we're going to have to just put the dots over the numbers. We don't want any decimals or fractions. Okay, so again we're going to get the x's by themselves. First we'll do this separately, and then we can put them on the same graph. So first I'll just get the -x by itself, so I'd be adding 2 to both sides. So I'd have -x is greater than or equal to a 2, and then I need to get rid of the -1, so I have x is less than or equal to a -2. Then for our other inequality, we just need to subtract 3. So x is greater than 3. So I have a -2, and then I have a positive 3. X is less than or equal to -2, so solid circle, shaded to the left. And then x is greater than 3, so open circle, shaded to the right. Okay? Right. Now looking at the product of chords and secants. When the chords intersect inside the circle, the products of the chord segments are equal. So here, if I multiply 4 times 3, that equals the same thing as 2 times 6. So 12 equals 12, that works out. When the chords intersect outside the circle, the product of the external segments and the whole segments are equal. So I have 3 times 3 plus 5 would equal 2 times 2 plus 10. So 3 times 8 is 24, and 2 times 12 equals 24. Okay, if one of the lines is a tangent, one product is the square of the tangent. So I again have the 3 times the sum of that whole line. So 3 times 3 plus 9 would equal 6 squared, because that's just a secant. It's only touching, it doesn't go through to split the line into different sections. Okay, so I have 3 times 3 plus 9, so that's 3 times 12, that's 36, and 6 squared is also 36, so it is true. So let's look at an example. So in this one, the chords are intersecting inside the circle. So I'm going to have x times 5 will equal 3 times 7. So x would equal 21 over 5. So we're basically applying these rules and finding the missing part or segment of the chords, okay? Okay, let's look at the next one. We have 4 times 4 plus x equals 3 times 3 plus 5. So 16 plus 4x, I'm just using the distributive property to get that, equals, and 3 plus 5 is 8. Okay, and then 3 times 8 is 24. Then I would subtract 16. So 4x equals 8. And then divide both sides by 4, so x equals 2. Alright, and the last one includes just that touching chord, the secant. So again, I would have 4 times 4 plus x. So it's this on the outside times the sum of both of those segments, equals 8 squared. So I would have 16 plus 4x equals 64. Subtract 16. So 4x equals 48. Divide both sides by 4. So x equals 12. So we can find the missing part. Okay, hopefully this helps you with your homework. If you have any questions, feel free to email me or call.